Okay, this is the final part of the RF signal generator project. As you can see, we're going to start with some ribbon cable, 15 centimeters of ribbon cable, and we also need 2 lots of 6-pin male headers. They normally come in 40 pins, so you just cut 6 off the end. And what we're going to do, we're going to tin the small parts of the small terminals of the header. And the idea of the tinning is that if we do the header and we also tin the bare wires of the ribbon cable, then it makes soldering easy because you can just heat the two together and they solder. It saves having to try and get a third hand from somewhere. So we're going to do that now. We're going to strip our ribbon cable. And again, for this project you're going to need 2 lengths of 15 centimeters ribbon cable. And they'll be used to join the display, which is mounted on the box, to the circuit board. So as I said earlier, we're just going to tin these connections. And then we're going to heat the tinned connections to the pin header, like so, and you'll see that they solder nicely. Now if you want to, an optional thing you can do is to use a hot glue gun just to heat where the cables go to the header, like I've done there, and that just helps prevent the cables from breaking off. And as you can see, the other end is stripped and tinned. Now then, on the LED module you can see the decimal points. Okay, the decimal points are going to stick upwards with the pins behind you, and the black wire goes to the left. Okay, so important that we get the connections right, otherwise you'll get a garbled display when you put it all together. So again, same method. We're going to tin the legs of the display. The ribbon cable's already been tinned, and again we're just going to melt them together. Of course, the other method is, you can use one of these helping hand things. They've got the little grips and the magnifying glass if you just wanted to solder the normal way. I just prefer that method. And we turn it round, and it's important the black aligns with the other black. So now we've turned it around, the black is now going to be on the right hand side. And I'll just double check that myself by looking at my okay. Again, feel to stop the video at any time, pause it, see where we are. Okay, here's the finished mount. We got a 1K pot, 2 10K pots, and 2 switches. RF out on the right, audio in on the left. The pots need a 7mm hole to be drilled. The switches are 6mm, and you can see we've glued in the display with hot glue gun. The phono connectors at the bottom need 6mm drill bits as well. And as you see on our diagram in a minute, we put a mounted resistor between 2 of the pots. And you can see the wiring there, and our real-time camera feed. And you can see how we've done the shielded cable there, the shield in the middle. We've used the yellow at the top and the blue at the bottom. And if you look at the blue side, you see we've mounted a diode on there. We've soldered a little diode with the black stripe pointing away from the cable. And you might want to pause this. This is the wiring diagram. You can see where everything is, how it's going to be wired up, where the ribbon cable colours connect to. Okay, so let's begin to wire it onto the main board. Now then, the reason we use shielded cable on some of the connections is to stop RF leaking. Because we're using a plastic box, you're going to get RF leakage, which you don't want. So here you can see we twist together the two shielded wires on our switch and we solder onto that pin there. The yellow wire we're going to solder to that top pin. And again, if you haven't got shielded cable with those same colours, just obviously substitute the colour and just remember what colour you substituted. Okay, and now we're going to solder the diode to the bottom pin, and again you see the little line is on the right hand side. And now we're going to solder the blue wire from our little array of variable resistors. That solders to the shield of the screen cable, as you can see. A little tricky because you've got quite a bit to solder to that middle earth pin. And our black wire from our variable resistors solders there, as you can see. And our yellow solders there. And now we're going to mount the parts to the other side of the board. Okay, so this is our RF out, I believe. Yeah, this is our RF out. That goes to the 1K variable resistor, the inner conductor to the top, and the outer braid to the 2 pins underneath. The reason we're doing it with 2 pins underneath is that those 2 pins are both ground, and I've found that just using a big blob of solder there helps us to mount all the grounds together without things falling apart. So as you can see, we've soldered the audio in. Second pin up is the inner conductor, and of course the ground shield is with the other ground shield. Okay, so the bottom end of the display where the decimal points are, as you can see, goes to the right hand connector, black to the bottom, and the upper side of the display goes to the left hand conductor, black to the bottom again. Again, we'll put the diagram back up on the screen in a minute, just to show you where it's what. Now here are 2 PP3 battery holders that we've glued into the bottom of the case. We're going to split the wires up. So the way this is going to work, the top connector will be negative to the board, bottom connector will be positive to the board, and the 2 middles will go to the switch. You'll see that as we mount this now. So I'm just going to tin the red wire, just make sure it solders properly. And the red wire goes to that bottom pin there. Now be very careful that that doesn't touch the yellow wire. That's extremely important. So make sure that that doesn't touch, because you don't want like 12 volts going up to your audio source. That could be a little nasty. Okay, so the negative of the top battery goes to our ground little assembly there. So again, a little tricky to solder, but yeah, you should be good. And again, make sure that doesn't touch the blue wire this time. And the 2 remaining cables between the batteries, like so, as you can see there, will go to the power switch. And this is where things get a little awkward, as you can see, just trying to arrange things. Okay. And there we go. Again, you can see the wires we're about to connect to the switch. Okay, and then again, just a little reminder, you can see there on the diagram how the batteries are arranged. Okay, and now we're going to solder those two wires to the switch. Of course, you don't have to have a 6-pin switch, just a normal 3-pin switch is fine. That's just all I had. Okay, so here's everything mounted, and we're just going to screw the board. You can see I drilled a couple of little holes in the board there. Just screw that in, and again, just a final plugging the display cables in. Decimal point bottom end to the right socket, top end of the display to the left socket, blacks to the bottom, as you can see there on the diagram again. And we're going to insert the batteries and hope for the best. And it comes on. So there we go, it's a relief. So we're just going to check everything. Power's working, tuning's working, fine tuning's working. RF output, we'll check that in a minute. That's the band switch, so now you can see we're tuning the AM band and also some IF frequencies. Everything's good, looking good, so let's just plug it in and test it all out. So now that we've got it assembled, we just need to do one adjustment. To do this, we need just to connect a piece of wire to the RF out, like so. Put it near a radio. We then need to connect in our audio source, playing at a fairly low volume. It can be music or anything that you want. I'm just going to do a test tone. Okay, and we switch it on. Oh, if I can remember. And then we just put it roughly in the middle somewhere. Yeah, that's good enough. Right. So what we now need to do is tune our radio in until we can sort of hear some audio. Like that. And the way this is adjusted, there's a middle point. At this point, the signal's very weak. You can just hear it's all interference. At this point the signal's very strong, but there's very little audio, so you need to adjust it to the middle point where you get the loudest audio. Which is about there. I mean, it's sort of middle way point. If the audio's too loud, it'll be distorted and the signal will be weak. So you've got to find that middle point where you get a good signal and a good volume. And then you're set to go. So we've got it on our signal generator now, and you can see it's generating our sine wave on the lower frequencies. Now, something I did forget to mention, the variable resistor on the board, the little 100k preset we mounted, what we need to do, we need to adjust that for a half signal. On the scope, that will probably be about 2 volts peak to peak. What you probably have to do is just put some audio in the signal generator, listen to it on a radio, and adjust the pot for the maximum volume. So that's the non-scope method. That 100k preset on the main board, you just adjust for maximum volume, yeah, after you've assembled it all. So anyway, you can see now we're adjusting our frequency on the scope, and we've got quite a nice sine wave there. And we're going to check the high frequencies. Again, yeah, you can just check them. I mean, you don't really need to actually check them as such. I mean, yeah, if you get a signal, it works, and if you get a readout on the frequency counter, then that's showing you that it's generating a signal as well. So what you do basically, you just put a radio next to the signal generator and check it that way. So these are just like final tests, as it were. So you can see we've got quite a good range there. So our shortwave goes from about 1.6 to just over 6 megs. Now the two coils on the main board you can adjust if you want to cover different parts. So the top coil is the shortwave coil. You could maybe adjust that if you wanted to cover like 5 to 12 megahertz or whatever. And again, the AM band you can adjust as well. So we now put an audio into the signal generator on the left hand side. You can see it on the scope, and of course if you put a radio next to it you'll hear it. We'll try it out with the radio in a few seconds. Okay, so now the radio test. We just put a little jumper lead on the inner connector of the phono lead there, and that will just act as a tiny little antenna. And we switch our radio on, and then we switch the signal generator on and tune it until we hear the tone on our radio. And we've put audio in on the left hand side, you'll hear that. Like so. So of course if you want to test a radio out or something, or you just want to do a little radio station around your room, you can just plug the left hand phono into an MP3 player or laptop and just play music for the signal generator, and just have that as your own little private radio station. And the reason again we done this as a first project is that if you, there's the inside by the way, when we do radio receivers and radio projects and you don't have any good AM stations near where you live, that's a great project to do. And also if you want to test and refurbish old vintage radio equipment, then you can do that too. So a very useful piece of test equipment. Okay, well thank you for watching, and I hope you build it alright. You can leave questions in the comments, and at some point we'll probably do another video with a questions and answers section and see how people get on with it. Thanks for watching, and we'll see you again soon for the next project, which will be a very, very simple, much simpler than the project we just done, a very simple radio receiver that even kids can make. Thank you for watching.